let us work on this WAEC question as we have it here, that the diagram below shows the orthographic view of a lever in third angle. Draw full size the isometric view of the lever, making X the lowest point. Let me read the question again. The diagram below shows the orthographic view of a lever in third angle. Draw full size the isometric view of the lever, making X the lowest point. So here we have the orthographic views of the lever in third angle projection. It means this is the plan, this is the front elevation, and this is the right end elevation. This is the right end elevation. So we are going to put this part together to obtain the isometric view of this object, as we have that the lowest point is here at point X. So let's see how we can construct this object. As I go on doing the construction, I'll be talking about dimensions that we have on it. Now, what we are going to do first is to draw the isometric view of this front elevation. Once you are able to bring out the isometric view of this front elevation, then the problem is completely solved. Let's see how we can do the isometric view of this front elevation of the lever. So what we are going to do first, so what we are to do first is to draw a short horizontal line. So we draw a short horizontal line here. So this is the short horizontal line, and on this short horizontal line I'm going to make a point on it, which is going to be represented with letter X, which is the lowest point. Now, as I said that we are going to make the construction of the given front elevation, so let's talk about the dimensions on the front elevation, as we have that the distance from here to here is this 35 millimeters that we are given here in the plan. Distance from this point to this point is 35 millimeters. And then we have that the thickness from here to here is 10 millimeters, that is showing to us here. So 10 millimeters from here to here is 10 millimeters. It means that the thickness from here to here also is also 10 millimeters, as shown here on the end elevation. Alright, so the height from here to here is 40 millimeters, that is given to us here in the end elevation. And then we also have that the distance from here to here is 15 millimeters, and then for this cut from here to here is 4 millimeters, from here to here is 4 millimeters, and then from this point to this point here is 10 millimeters, from here to here is 5, from here to here is 4, from here to here is 5. So let's bring out the isometric view of this front elevation first. So once we are able to do that, as I said, the problem is solved. Let's start. Okay, so we are making use of 30 degrees set square. So with 30 degrees set square being set on the T-square like this, so draw a line in this direction. So draw a line in this direction. Okay, so now, so let's look at what we have here. So the total from here to here, we read the addition of this 35 and this 10. The total from here to here will be addition of this 35 and this 10. Okay, that is 45 millimeters. So we take a measurement of 45 millimeters from this point, 45 millimeters from this point. So this is so let me take that 35. So here I have this 35, and then 10 in addition to make it 45. So here we have 45 millimeters. Okay, so at this point here, I'm going to draw a vertical line at this point, a short vertical line at this point. So we have this. Okay, so on this vertical line, I will take a measurement of 15 millimeters up. So this is 15 millimeters here. Okay, then I will come to this point here. I will draw a vertical line up like this, where we have this 45. So draw a vertical line up. So let it go up like this. Okay, then at this point here, I'm going to draw a line in this direction. So set the set square like this and draw a line in this direction. Okay, so we have it like this. So where we have this 10 millimeters from here to here, which is the 35 that we took from here to here, so take a vertical line up. Okay, so I need to extend this line a little bit inward, so let it go in a bit. So we have this. Then at this point here, okay, so we draw a vertical line, but I'm not going to draw it directly from this point. I'll just come on to this line and draw a line like this, okay? So we have this. Now, so as we have that, the height is 40 millimeters from here to here. That means from this level to this level is 40 millimeters. So I will take a measurement of 40 millimeters off from this point. So this is 40 millimeters, okay? So that 10 millimeters that we have from here to here is also part of that 40, that is from here to here is 10 millimeters, so which is also part of that 40. So what I will do is that I will come down, I'll come to this point, take 10 millimeters down, okay? Then at this point here, I'm going to draw a line. I'm going to draw a line from this point to touch this line. Then I take it backward like this, and I'll come to this point also. I will draw a line in this direction. All right, so let's look at what we have for us to know the length that we have from here to here. So the length from here to here, okay, is this. So the length from here to, so I will have that from, okay, so from this point to this point is 60 millimeters. From here to here is 60 millimeters. Then we now have that the radius of this semicircle is 20 millimeters. So we are going to add the radius of this, because distance from here to here now is 20 millimeters, which is the radius of this semicircle. So we are going to add this 20 and this 60 together. That will give us 80 millimeters. Okay. So if we have already, have 45 to this point, okay, we already have distance of 45 from here to here, then the balance will now be 35 millimeters. Okay. So what we just have, from here to this end is 80 millimeters, and we already have 45 millimeters from here to here. So if we subtract 45 from 80, the balance will be 35 millimeters. So what we have to do now is that we take a measurement of 35 millimeters from this point, 35 millimeters from here. So here is 35. Okay, so here is 35 millimeters from this point. So here I have 35 millimeters. All right, so then at this point here, I can draw a vertical line at this point to complete the front elevation, the isometric view of the front elevation. So here we have the isometric view of the front elevation as we have it here. Now, let's work on these features that we have here, So we have to take a measurement. So we come to the front here. I have to make use of this particular one. So we come to the front here, we take 40 millimeters down, 4 millimeters, not 40. So this is 4 millimeters down, okay? And then we take another 4 millimeters down from this point. This is 4 millimeters, okay? Then we come here, up here, so we take 10 millimeters. So from this point, take 10 millimeters inward, and we take what? And we take 5 millimeters. This is 5 millimeters, and then we take 4. So this is 4 millimeters. And then we take 5, this is 5 millimeters. All right, so at this point with 30 degrees set square, okay, we have to draw a line. So from this point, we draw a line in this direction, inward like this. Okay, then we come to this point, we also draw a line from this point in this direction. So we have this now, and then so we are going to come to this point here, so we draw a vertical line. So we draw a vertical line down here to touch this, and we also draw a vertical line down here to touch this. So at this point here, I'm going to draw a vertical line from this point, okay? So just take it from here to here, and then come to this point here, so take it from here to here. So the feature that we have here, so this feature that we have at this point has been created here, as you can see it here now. So as I said, that if you are able to make the isometric view of the front elevation, so the problem is solved. So let's see how true that is. So this is going to be a three-dimensional object, okay? So now, so let us make it three-dimensional. So just come to this point here. So come to this point and draw a line in this direction like this. So come to this point up here. So draw a line in this direction. Then there's going to be a line at this point, so draw a line in this direction. So come to this point also, at this point, draw a line in this direction, and there'll be a line at this point. draw a line like this to touch this line. Then we come to this point here, so come to this point and draw a line in this direction. So come up here at this point, so draw a line in this direction. Then we come to this point here and we draw a line in this direction. So we have this now. All right, so now, so what is the width? So what is the width? What is the width? So from here to here, so what is the width from here to here, or the width from here to here? So the width from here to here is equal to the diameter of this semicircle. So is equal to the diameter of this semicircle. So the diameter of this circle would be what? Would be 40 millimeters. That is 20. Okay, radius is 20. From here to here is 20, and from here to here is 20, and that will be 40 millimeters. So we take a measurement of 40 millimeters from this point. So 40 millimeters from this point here. So here is 40 millimeters. Here we have 40 millimeters. Okay. Then let me come and take that 40 at this end here. So let me take 40 at this end. So from this point, so we have 40 millimeters to this side. This is 40 millimeters. So what we have to do here is that, so we come to this point. Okay. So from this point, draw a vertical line to touch this line. And then from this point here, so here from this point, so draw a line, set the set square like this, draw a line from here to here to touch this line. And then we are also going to draw, so along this line on this side, we draw the line like this. And at this point here, so draw a vertical line to touch this line. We have this. So we have to come back to this point. So there's going to be a line at this point that will go inward like this because of this cut that we have here. So take note of that. And then for this one, I've already taken 40 millimeters here. So I'm going to connect this together. So we have this now. All right, so now, so you can see, as I said, that once you are able to produce the isometric view or the front elevation, the problem is solved. Okay, now we have a semicircle here. There is a curve along this part that we have here, so whose radius is 20 millimeters. So look at what we have from here to here. So what is distance from here to here? So let's measure it. So distance here is 45 millimeters. So I'm going to create an isometric square on this surface whose length will be 40 millimeters, and this is how to go about it. So I'll come to this point and take a measurement of 40 millimeters to this side. Okay, then I'm going to transfer this. So I will transfer it. So I'll transfer this distance. I'll transfer it to this side to touch this. Okay, so I formed an isometric square here. So let me label it so that we can see it. So if I call this point, this is point A here. Okay, so this is point A, and I call this point, I call it point B. So this is point B, and I call this point, this is point C, and this point here, I call it point D. So this is isometric square ABCD. Okay, so whenever we have to construct an isometric curve, an isometric circle, we have to put it in an isometric square. Okay, so that is very, very important. Now I've created an isometric square here. So what I'm going to do is that these 40 millimeters that we have here, I'm going to break it down into two. That is 20 millimeters each. So from this point here, I'll take 20 millimeters to this side. This is 20, and I'll come here also and then break this down into two. That is 20, 20. So this is 20 millimeters here. So I'm going to transfer these distances. I'm going to transfer them to the other side. So I will transfer this. So from this point, I will draw a line. So transfer this point to this side, and then I will turn like this and also transfer this to this side. All right, so now, so the next thing that we are going to do is that we are going to connect this point A and C together, which is going to be the longest diagonal of the square. So it goes like this. So we have this. All right, so let's work on the semicircle. So let's produce isometric semicircle on this face. So to do that, so what we have to do is that we are going to connect this point B and this point together. So this point B and this point, we connect them together like this. So let me label this point. Let's call this, say this is point E here. Okay, and we add this point to the point F. So this is point G, and this is point H here. So we have this now. So we connect point B and E together. So when you are working on this. So it is point B and E that you have to connect together. So I have this. Okay, so I'll take the compass. So put the pin of the compass at this point. So where this line intersect the longest diagonal. So put the pin here and extend the pen point to point H. So extend the pen point. So extend the pen point to point H here like this. Okay. So just take it easy. So and then we are going to draw a curve. So we draw an arc. So we draw an arc from this point. So I need to make it easy. So it's all right. So I'll press this down. So then draw an arc like this. Okay. So here we have what we have. So it goes like this. All right. So we are going to. So what I'm going to do here. So I will still manage. So probably the compass is not functioning well. So I'm going to just use my French curve to create this and to complete this arc like this. So we have this now. So just don't have to clean it. So because of time. So all right. So then putting the pin on the compass at this point, and I will extend the pen point here. So extend the pen point here. All right. So if I draw this, so this goes in this direction. All right. So we have what we have. The semicircle on this face now. So we have it on this face. Okay, we have it on this face. But the curve is also down here. So that has to be shown. So how can we show that? So what we have to do is that we come to this point. So come to this point here at this point and draw a vertical line down like this. Okay, and then come to this point. Also draw a vertical line down like this. Okay, so now we are going to come down from this point. So come down from this point here. So here we have it from this point. So take the thickness is 10 millimeters. So take a measurement of 10 millimeters down here. So that 10 millimeters will not really work. Okay, just take 10 millimeters down. So with my French curve, I'm going to blend this together. So with the French curve, I will blend these 2 points, I will blend them together with the French curve. So just set the French curve like this, okay, and blend these 2 points. So blend them together to form a curve like this. Okay, so we form a curve like this. So that is the curve down here. So then make this line, make it a thick line like this from here to here. All right, so we have formed the curve as we have it here. Another thing that we have here that we have to show is this circular hole. So we are going to produce a semicircle, a circle in this center. Okay, so you can see the center of this semicircle and the center of this circle, they are at the same point here. Okay, so the diameter of this circle is 14 millimeters. So it's a very small circle. So this is what I'm going to do. I'm going to create an isometric square here. So take 7 millimeters to the left side from the center, 7 millimeters to the right side from the center, and then so here we also take 7 millimeters from the center. So we take it to the so take 7 millimeters to the left side and take 7 millimeters to the right side. We have this. So we form an isometric square also on this face. So form an isometric square on this face like this. So here we have this, and then so we come to this point. So we have this. Okay, so looking at what we have here, so I'm going to use my hand to form the isometric circle here. So because it's a very small circle, so I'm going to connect this point like this. Isometric circle usually appear as an ellipse on an isometric object. So I'll just use my hand to form it like this. All right, so if you can make use of your compass, please make use of it. But for me, to make use of the compass, it will not be stable. Okay, so that will be taking time. So you can see I formed the isometric circle. So it's a hole. So we are going to leave it like this. So then what we have to do, so make this line a thick line. We have completed the object already. So we make this line a thick line from here to here. So make this line a thick line from here to here. So make this line a thick line from here to here. And then make this line a thick line from here to here. So this line from this point, so to this end, so make it a thick line like this. And then so this line, so make it a thick line from here to here. And this one, make it a thick line from here to here, okay? Here to here, and from here to here, make it a thick line. So we have this. Alright, so this line, so make it a thick line from here to here, and then make this a thick line from here to here. So then come to this end, so make this line a thick line, and make this line a thick line. And then so this line here, so make it a thick line from here down, okay? Make this also a thick line from here to here. So we have this. And then this line, so make it a thick line from here to this end like this. Make this a thick line from here to here. And then so make this a thick line from here to here. So we have this, okay? Alright, so this line also, so make it a thick line from here to here. So blend this together. And then this line, we have to make it a thick line from here to here. So make this line at this edge, so make it a thick line from here to here. And then so which one do we have again? So this line, make it a thick line, so make this a thick line, and then make this line a thick line, and then come to this point here. This line is very important, make it a thick line. So then this line at the edge here, we also make it a thick line. So looking at what we have here, we have completed the isometric view of these orthographic views, as we are given as simple as I've done it here. All you have to do is to practice. Thank you, and God bless you.